So the next few problems here, problems 7, 8, and 9, all start with this instruction here, and they build upon it using kind of the same or modified versions of that function. So I'm going to start by importing turtle, and start by defining a new function called drawStar that just takes a turtle. And we don't have to worry about anything yet, like taking an angle or number of points or side lengths, because it's telling us to simply draw a 5-pointed star with side lengths of 100 units. So we're going to hard code all of that, and we're going to say that this uses turtle t to draw 5-pointed star of size 100. And then we can change that doc type later if we decide to make a general version of this function. But right now that will work. So the first thing we want to do is, if we assume that our turtle starts facing right, like all turtles do when we instantiate them, he will be up in this top left corner facing right. So what we can do is just have him draw this line first, and then come in and go this way, and come in and go this way, and come in and go this way, and come in and go this way. So I don't know off the top of my head what the exact angle that we need here, but thankfully we can figure it out pretty easily. Just by some messing about. If we wanted to figure it out, we could Google the answer to how many angles, or what's the angle of the inside angle of a 5-pointed star. But we'll just mess around with it. So we want him to go forward 100. And I need to make sure that I put this into a loop. So for I in range, I think it'll be 5 in this case, because we want him to draw 5 lines. So 1, 2, 3, 4, 5. Yeah, it should be 5. So for I in range 5, he's going to go forward 100 degrees, and then he's going to turn right. So it's going to be more than 90. It's going to be somewhere between 90 and 180. Let's call it... let's call it 145 and see what that does. So then that's good enough. That will work to draw something. We don't know if it's actually going to be a correct star yet, but hopefully. So hopefully by now, if you're following along, you will have gotten pretty adept at entering these few lines of starter code that we do every single time. I'm going to keep using Alex as my turtle. Turtle.turtle. And then I'm going to give him a background color of black this time, because that's what they have up here. And I'm going to give him a pen size of 3, just to keep it similar to what we've done before. And I'm going to change his speed up to 5. There we go. Then I'm going to draw a star using the function that we made, and then pass in Alex as my turtle. And then of course I'm going to end with wn exit on click. Obviously, if you're using something other than wn as your variable name for your screen, you will want to do that instead. So let's run it and see what that gives us. Oh, whoops. Oh, I messed up. Alex does not get a background color. He gets a regular color. Alright, so that's not perfect. That's not quite right. It needs to be a little bit less, I think. Maybe 140? Let's see what that does. Nope, that's too much. So 142. No, 143, maybe? I'm sure there is like an actual method to figure this out, but 144, it seems, worked. 144 seems like it worked correctly, so that's what we'll go with. So that's all we need to do. That is this definition of drawStar. Now we're going to continue to use that definition in order to solve this next couple of problems. So I'm just going to copy all this down below, down here, this next problem, and we'll just head right on into it. So it's asking us to extend the program above by drawing 5 stars, but between each, it wants us to pick up the pen, move forward by 350 units, turn right by 144, put the pen down, and draw the next star. So we can do that. We can absolutely do that. It's very simple. We don't actually need to change the function for this. What we're just going to do is change our main program. So it says after we draw each star, it wants us to move forward pick up the pen, move forward 350, and then turn right by 144. So let's do exactly that. We will then have Alex pick his pen up, and he will move forward 350, and he will turn right 144, and he will put his pen down. And we're going to, of course, shove all of this into a for loop, because we're going to have to do it 5 times according to what they want. That should work. That should be all we need to do. So let's run it and see what happens. Obviously, we're not going to be able to see this because Alex started in the middle, which means that he is now hanging out somewhere over here, which is not what we want, obviously. Oh, Turtle has no attribute pin on line 23. What did I do wrong here? Oh, hopefully you saw that, because that was entirely wrong. Okay, let's try running it again, even though we know he's still going to disappear off the side here. But hopefully he will come back, because essentially what we're doing is making a star out of stars, if you think about it. And we'll show you exactly that is the case momentarily. So let me instead start by picking Alex's pin up here and setting him into a better position. So I'm going to send Alex to, let's see, I want him on X0, and I want him on Y. No, I don't want him on X0, because X0 is the middle of the screen, the origin. Let's put him X180 and Y0. Should work. And then I'm going to drop his pin down again, making sure that I actually call the function correctly this time. And run that. Alright, so this should be just fine this time. So he's went a little bit low. I'll move him up in a second on his starting point. But that does fulfill the basic question here that they asked us to do. Then they want us to see what it would look like if you didn't pick up the pen. So I'm going to change where he starts off at here to move him up just a little bit so he doesn't get cut off along the bottom like that. And instead, I'm going to just leave the pin down as we go through this. So imagine what you think it would look like. Okay. Now let's run it. So what we get, of course, is a star where the points of the star are made out of stars themselves, which is kind of a neat thing. Alright, so last thing we're going to do with our star program here, our draw star function, is we're going to change it a little bit to make it work for an n-pointed star. So it's going to involve a little bit of math, but thankfully the textbook kind of provides that math for us in the form of their instructions here. So it wants us to extend it to draw an n-pointed star, and n must be an odd number greater or equal to 3. So that tells us kind of what we need to know. So if I was, think about how you would try to figure this out if you didn't know exactly how to do it. So when we did this before, we just kind of like figured out what the correct angle was for this through trial and error when we were trying to figure out how to draw a 5 pointed star. So that was good for then, but obviously we can't do that for every single time we want to change the number of points that we have on our star. So what we need to do is figure out what the generalized version of this angle is. So we know that it works for 5 and 144. So I'm just gonna real quickly do 5 times 144 and see that's 720. Okay, so 720. So if I do 720 divided by 3, I get 240. So let me go back to the textbook here and try changing this to that number, which was 240. So I'm going to change it to 240. And instead of 5, I'm going to use 3. And we'll just get rid of all this extra stuff, obviously. And we're just going to have Alex draw us a star. So this should not draw a 5-pointed star this time. It should draw at least our attempt at what we think a 3-pointed star is going to be, which is, of course, just a triangle going in the opposite direction, right? So what we have there is 240 times 3 equals 720, and 720 divided by 5 equals 144. So it looks like 720 is kind of the magic number here for the angles of a star. So if we wanted to then do 7 as our stars, let's do 720 divided by 7. And see, it should be about 102.8, so about 103. Python will figure out the exact answer for that if we put it in here. So it needs to be an odd number greater than or equal to 3. So instead of hard coding in the number of points that we want, we're going to use a number for that. So I'm going to call it points. And say pass in turtle, pass in points. And instead of hard coding the angle, what we're going to do is figure out the angle kind of algorithmically, programmatically here by doing 720, which we think is the correct answer, divided by points. So now if we tell Alex to draw a star of 3 points, we should still get our triangle. If we ask him to draw a star of 5 points, we should get our star. Now if we ask him to draw a star of 7 points, we should get a 7-pointed star. And there we go. If we ask him to draw a star of 9 points, we should get a 9-pointed star. So now, of course, all of this is going to break down when we ask him to draw an even pointed star, right? Because the problem tells us it's not going to work. And it doesn't work because if you have an even number divided by 720, what you're going to get is, instead of that kind of wonky angle, you're going to get an angle that is kind of evenly divisible by 180 or 90, which is going to cause your angles, instead of turning in that kind of wonky, all like out of shape way, it's going to instead turn them in ways that match up other polygons, just because instead of churning, so for example, if I wanted to churn 270 degrees, I would churn 270 degrees this way, which is actually just a 90-degree turn to the left, right? And so it will only work with odd numbered star points. And that's it. That's our generalized star function. You can see it works pretty much exactly the same as before, just once we figured out the actual rule for the number of points, the same way we did up top with our draw square and changing it into draw polygon. It's the exact same thing that we're doing here.